It's great to speak with you again, Tina. It's been about a year since we've talked, and today I'm looking forward to hearing your views on the topic of variety in big data and specifically around text analytics. Um, Before we start, can you provide a brief background of yourself?
Yes, thank you, Dustin. It's a pleasure to speak with you again. I'm Tina Groves. I'm a senior product manager with IBM. I work in product strategy in the big data and analytics area. I've been working in this area for the last, a little over 2 years at this point. And last spring, I shifted my focus specifically to look at text analytics.
Thank you. Well, my first question regarding this topic, what's the latest buzz in big data?
Big data is it's been, I'll say a term that's been used so often now that many people just, I don't use the term to say they roll their eyes, but it does become a little hard to keep up with everyone claiming that they're doing something in big data. The three trends that I'm seeing, though, are about solving the problems with addressing not just very large volumes of data, but how to achieve the kind of analytics experience that we've enjoyed for several decades now with relational databases, and also how to tackle the types of data that can be stored in Hadoop and the NoSQL databases. So what we're seeing is a great deal of innovation around dynamic SQL or interactive SQL, so that one can get that put the traditional and analytical tools on top of these new forms of data storage. You can see that there's a lot of concerns around security and privacy for companies that have gone past a pilot stage and they're looking at bringing in, not bringing in their data, but they want to share data as a data aggregator or as a data collector. And lastly, you see a lot of information, a lot of innovation around tools that are around data wrangling. So we've moved past the data scientist who's analyzing the data and looking at, well, how can we take all this messy data that's normally not joined together, and how can we bring it together in a way that, again, creates that experience that we're used to seeing on the relational database side. And data wrangling, a term that was coined largely by Stanford University, and you can see new products like Trifacta and Pexata claiming to address this space. One of the areas that's very common is how to transform text into typical rows and columns that you see in a traditional environment, so that you can then use it in an analytical model.
Well, in supply chain, there's all kinds of paper and email and PDF attachments. How can this type of how can this be turned into data?
It's a great question, Dustin. In any kind of environment, especially one where you're taking data from, I'll say you're in the middle of a logistics chain, how do you manage all this data? And in some cases, over the last decade, I've seen many clients barcoding the information. They just basically use a barcode. But that somehow, that helps fine with a lot of the structured data. If you've scanned a piece of paper in, it's been transformed into its piece parts. Sometimes there's digital interchange. But the tough part is when somebody's typed in a note, or there's special instructions, or there's something in the email that's related to that PDF attachment. And that's where the text analytics really comes into play. Nowadays, there's you'll see is more embedded technology to help transform those special instructions into instructions that can then be tracked, for example, in a supply chain context. How this is turned into data? Well, I think that's going to require some more questions because it's a very complex area.
Well, why is analyzing text so hard?
Well, it's something I've been learning from the scientists that I work with at IBM who specialize in natural language processing, and I have a very, I'll say, a greater appreciation from today than what I had 6 months back. So analyzing text where you can just do straight word matching, that's, we'll say is really text parsing. And that's not that hard. If I see the word Tina in a piece of text, then Tina represents a person, and then we can have a person field with the word, with my name Tina in it. Or detecting, for example, the names of cities and locations or countries can be easily done. What becomes more difficult is, let's say you're analyzing customer support records, which can happen in supply chain, calls that are coming in about people complaining. How can you infer, for example, the sentiment that that customer has? Are they a little angry, somewhat complacent? How would you then use that mood or that person's sentiment as an input into your decision making? And then combine that, for example, is this the first time the person's called in, the second time, the third time, and what's on the line? Is there a parcel that's worth a few bucks, or is this a parcel that represents a birthday present for someone very close to to the sender? So in those cases, you want to be able to combine both quantitative and qualitative information, and that's where we get into that moving from just text parsing and detecting specific words into understanding the perception of the person. What is their awareness? What is their opinion? I've already mentioned sentiment, and that really requires more skill in linguistics and language use than, I'll just say, normal text detection or text recognition.
What technologies can supply chain consider to address this challenge?
That's another great question. It's in the big data space. This area is evolving very quickly. So 3 months from now, the answer may change a little bit. And if you're using Hadoop, many of the technologies today tend to be very developer-oriented. So you'll see R and Python scripts being developed, leveraging the natural language processing toolkits, which is a very costly, very time-consuming way to address text analytics. But I say it is an area that's evolving quite quickly. If you're dealing with a lot of documents, for example, we were talking earlier about email and PDF attachments. There is an area around content management called content analytics, which can facilitate pulling out the information more quickly, and many of those technologies will have additional toolkits or what they might call annotators or extractors to infer opinion, survey, or opinion, sentiment, or awareness factors. A third type of technology is around natural language processing toolkits, like you see from Basis Technology or an open source one called Gate. IBM also has, of course, these technologies, but because of the difficulty in using them and the developer focus, we tend to bundle them in our products so that it's hidden and it's one of the engines that we use then to drive people's requests, their interaction with the information. So that's three. There's just to recap, the developer-oriented technologies like the R or Python toolkits. There's the applications that you'd see with content analytics. And the third one is kind of this middle ground around in the data wrangling space where the natural language processing engines are embedded as part of the user interface.
And what do you see in the future?
Well, this is another good question. In the future, this area is just so hard to do. Once you get past the basics and the amount of skill that's needed, both in some cases statistical backgrounds, if you're going to do clustering on words, if you're going to understand, for example, how this turns into fraud. I had one customer who was looking at automating their accounts payable area, and this was a Memorial Hospital. And after they finished basically automating this process, they found all kinds of problems, unusual behavior, let's put it that way. Well, the behavior was suspicious enough around some contracts are being handled, they engaged the FBI to investigate. At the end of their investigation, the FBI successfully prosecuted several employees for bribery and some vendors that the hospital was dealing with for bid rigging. So there's the outcome of that investigation was that because this area is hard, the Memorial Hospital actually created an application that they now resell to other hospital systems that are tackling a similar problem. So I see that the trend will be to encapsulate the algorithms needed to analyze text. So it wouldn't be just generic sentiment. It'll be sentiment for supply chain vendors, or even more specifically, sentiment for vendors that are in logistics planning and sentiment in the terms of people who are in the manufacturing area. People who do warranty analysis, for example, are looking for the shortest time to results that they can engage, that they can obtain. So in the future, I see that the developer tools will eventually become less important, and this type of technology will be baked into the applications.
Well, thanks, Tina, for sharing today.
Well, thank you, Dustin, for the opportunity to speak with you and your audience again.